So first, I would like to introduce Dr. Pankaj Mukhija. Dr. Pankaj Mukhija is an accomplished academician and researcher in the field of automation and control systems. He is holding a PhD degree from the prestigious IIT Delhi, and he has established himself as a leading expert in this domain. As an assistant professor at NIT Delhi, Dr. Mukhija is dedicated to advancing knowledge and nurturing the next generation of engineers. His teaching prowess is complemented by a profound research portfolio with notable contributions in both journals and conferences. Dr. Mukhija's expertise extends across all the intricacies of automation and control systems, making him a sought after authority in this critical area of engineering. His commitment to innovation and a keen analytical mind have resulted in a series of impactful publications enriching the academic landscape. Now I request Dr. Pankaj Mukhija to say a few words. Please, sir.
Okay. Good morning, everyone. Am I audible? Can you please confirm?
Yes, you are audible.
Okay. Thank you. Thanks for such a wonderful introduction. Um, I'm really happy that this MIT University is organizing this conference, and we have this dedicated session on this control. And I hope that today's session will be fruitful for everyone, all the participants, and all the presenters, and for us also. We'll get new insights and whatever that new research is going on in the field of this control system. So with this, I wish everyone all the best for the presentation and have a good luck. Okay, thank you.
Sir, can you please turn on your camera? Now, next, I would like to introduce our second session chair, Dr. Amit Kumar Singh. Dr. Amit Kumar Singh is associated with the Vignan University, Guntur, as an assistant professor in biomedical engineering department. As a skilled research-oriented instructor with a doctorate degree in biomedical instrumentation and biosensors from IIT Delhi, he prepared himself to benefit the society in this role substantially. He has completed his BTech and ME from NITR Chandigarh in Electronics Instrumentation and Control and PG Diploma in Embedded System Design from SCL Mohali. He has more than 13 years of experience, 5 years in this industry and 8 years in teaching. He has 8 renowned journal and conference papers published. This research work has the novelty of filing 5 patents. He has completed 3 government research projects sanctioned in the individual category. His research ideas were also recognized by different agencies like BIRAC and ICMR. Now I request the sir to say a few words, please.
Hello. Hello. Can you hear me, madam?
Yes, sir.
Okay. Very thankful for the MIT University. My name is Dr. Amit. As madam has already given me my brief, I am currently associated with the Vignan University, Guntur. And I'm thankful for the MIT University for providing me the opportunity to session this chair on the control system. And madam, I think we can start now because already it is 15 minutes late.
So before we start with the paper presentation, I request all the presenters to kindly note that the presentation will be of 8 minutes followed by 2 minutes for question answers. So let us begin with the first paper, that is paper ID 6. I request paper ID 6 to share the screen and present the paper on active cell balancing on lithium ion battery during the charging and discharging.
Hello. My voice is audible.
Yes, you are audible.
Okay. Can I start?
Yes, you can start.
Okay. So first of all, good morning, one and all of you present here. Myself, Jatin Shoran from Lovely Professional University. Today I am here to present my research topic on active cell balancing of lithium-ion battery during charging and discharging mode. These are the content of my presentation. So first of all, we discussed about introduction. In introduction, we discussed about battery management system. So battery management system.
Sorry to interrupt. Can you please switch on your camera?
Okay.
I request all the participants, please turn on your camera while giving your presentation. Please note this. Mr. Jatin, please continue with your presentation and turn on your camera.
Okay. So first of all, we discussed about battery management system. So it is an electronic system that manages the charging and discharging and overall performance of the battery pack. It ensures the safe and efficient operation of batteries, and it extends the lifespan and it maximizes the performance. Its primary function includes that state estimation, SOC estimation, share balancing, and thermal management. So next we discuss about importance of battery management system. So in battery management system ensure a safe and reliable operation of battery management, that it prevent from overcharging, over discharging, and it maximize the performance while managing the operation efficiency. Battery management system is crucial in applications such as in electrical vehicle, renewable energy system. There are some benefits of battery management system, that it extend battery life and it optimize charging and discharging process to prevent from aging, balance cell voltage to maintain constant performance, and it improve performance by estimate accurate SOC. And it enables better energy planning and utilization. Here are some function of battery management system that include data equation, SOC estimation, SOH estimation, thermal management, load management, and cell balancing. So first of all, we discussed about the data equation. Data equation involves the collecting, processing, and storing the data from various sensors and component in BMS. The BMS uses the data to monitor the health and performance of battery to make decisions related to charging and discharging, and it has a communication interface that allows the BMS to communicate with system or user interface. Next, we discussed about SOC estimation. SOC estimation calculates the remaining capacity of the battery. Its several factors affect the accuracy of SOC estimation in a battery, that include temperature, battery condition, charging and discharging. And the accurate SOC estimation enables effective energy management that prevent from overcharging and over discharging. Next is a state of health estimation. So state of health monitoring assesses the health and degradation of the battery time. And the SOH estimation helps to determine the remaining capacity, performance, and lifespan of the battery, and it monitors to determine battery life expectancy to maintain and to maintenance and for replacements. Next is thermal management. So in thermal management, it ensures the battery operation with the operating temperature range. It involves monitoring the temperature of the battery cells and implementing cooling or heating mechanism as needed. It prevents from overheating by activating cooling system or adjusting the charging and discharging rate according to that. Next is load management. So in BMS manages the distribution of powers to loads connected to the system, and it's prioritized power delivery based on load requirement, battery capacity, and system constraints. Next technique is cell balancing. So in my research paper, I uses the cell balancing technique. So in cell balancing, it performs cell balancing to equalize the charge level of a individual cell. It redistributed energy among all cells to prevent from overcharging or undercharging of the cells. And cell balance it extends the overall battery life and it enhances the performance of the battery. Cell balancing it is necessary to prevent from it necessary to prevent capacity from mismatch, and it maximizes the performance and lifespan. It in a BMS uses various techniques to achieve cell balancing is like that passive cell balancing, active cell balancing. These are the some most common example of cell balancing. Next, we discuss about the need of cell balancing. So the cell balancing is needed in uniform performance. So in that it ensure that all the cell in battery pack it maintains similar voltage level. It promote consistency and and optimal overall performance. It is needed to extend the lifespan. It enhance the efficiency of the battery. It is used for safety improvements. In that cell voltage can lead to safety hazards like thermal runaway. Balancing mitigation these risk by ensuring cell operation within the safe voltage ranges. Next is the importance of cell balancing. So cell balancing is important for maximizing battery life, that it prevents from overcharging of some cell and undercharging of others. So it promotes uniform cell voltage and it extends the overall battery lifespan and minimizing the stress and degradation. Next is optimize energy capacity. So in that balancing ensure that each cell in the battery contributes to its maximum energy storage capacity. It enhances the overall efficiency performance of the pack, and it is also important for consistent performance. So in that balanced cell provides consistent voltage output during the discharge rate and preventing voltage drop and ensuring steady state performance through the battery life. Next is the type of cell balancing. So first of all, we discuss about the passive cell balancing. So passive cell balancing is a straightforward and a low-cost method that it is achieved by using balancing resistors connected in parallel with each cell. The resistor allow excess charge to dissipate as heat. It equalizes the cell voltage, and it is suitable for lower voltage differences. Next type of cell balancing is active cell balancing technique. So active cell balancing is more sophisticated and efficient techniques for maintaining cell uniformity. It allows for faster and more precise balancing for the cell. It actively transfers charges from higher voltage cells to lower voltage cell and it reduces voltage differences. So active cell balancing techniques include charge redistribution, charging equalization, and state of charge transfer. The objective of the study. So in the research paper, the objective of study is that to utilizes the cell balancing system for maintaining the battery voltage profile across the cell under various charging and discharging conditions. The study aims to investigate the various cell balancing method like passive and active cell balancing. Next objective is that to develop an active cell balancing system for a set of lithium ion batteries, and it optimizes the performance to ensure the uniform and efficient distribution of charge among individual cells during the charging and discharging mode. At the end, the implementation of bidirectional converter is achieved for the charging and discharging process of the battery. Methodology of this study. In this research, the technology employ active cell balancing approach. This technique is ensure that all the cell have equal SOC overall. The DC to DC bidirectional converter is used for the charging and discharging the battery. When one cell has the higher voltage and it transfer the voltage from one cell to another cell, so the balance circuit of a bidirectional converter is used to provide the external supply to the battery for charging again to continue the process. So here the inductor balancing methods is used for because it offers a quick comparison time as compared to other balancing techniques, and it has a strong balancing current. So the idea is to move energy transfer from higher voltage cells to lower voltage cell in the system. This is the single line diagram of inductor-based active cell balancing system. And this one is the single line diagram of DC to DC bidirectional converter. So here are two type of process. The first process involves to minimize energy consumption, where within the inductor from the cell from the cell switch 1, switch 3 and switch 5 are turned on, and while other switches are turned off. And in the second stage, switch 2 and switch 4 and switch 6 are turned on and other are off. So in this technique, here are four cells are used that are connected in series. So the lower voltage cell is a cell 4 and the higher voltage cell is cell 1. So to balance the cell voltage, the technique first transfer a large amount of charges from cell 1 to cell 2, then cell 2 to cell 3.
Hello.
Hello?
Hello, Jatin. Already it is 10 plus minutes. So please wind up fast.
Okay, sir. Okay. So this method is simply compare voltage of two cells and it transfer the excess amount from one cell to another. This is the simulation model of DC to DC bidirectional converter, and this is the simulation model of inductor-based active cell balancing system. These are the results of unbalanced voltage cell. In the result, the pink line represent the first cell voltage. The pink line represents the first cell voltage, and the second cell voltage is indicated by the blue line, and the third cell voltage is shown in the green color. And all the cell are have unbalanced and have different voltage levels. So to overcome this uncertainty, we used a balanced system. This is the diagram of balanced voltage system. In this result, it is shown that all the cell are in the result, it is shown that all the cells are in balanced condition, and the representation of battery 1 voltage is by the pink color, and the second cell voltage is indicated by blue line, third cell voltage is indicated by the green red line, and fourth cell indicated is represented by the green color. So in this it is shown that all the cells are charged at the nominal voltage, and step time of 0.5 second is provided to charge the cells. So all the cells are starts charging at the time of 0.5 second to 1 second, and after that voltage goes up to 5.5 to approximately 6 volt, and the after the process the all cells are start discharging, and again it come back in the same process. This is the statistical comparison of the result between the balanced voltage and unbalanced voltage. So in the result, it can be seen that at the time of 0.2 second in the unbalanced condition, the battery 1 voltage level reaches up to 5.68 something, and whereas in under unbalanced condition, so the battery level goes up to 5.4. At the time of 2 seconds, the under balanced condition, the battery 1 voltage goes up to 5.6, and in unbalanced battery voltage goes up to 5.60 volts. So the voltage level of unbalanced voltage system decreases more as compared to the balanced voltage system. In the conclusion, the idea of inductor-based balancing cell system was examined in this work, and the cell balancing is essential aspect of BMS to ensure the optimal performance and longevity of battery packs. The implementation of active cell balancing system is used to balance the voltage and SOC of the cell in a battery pack that prevents from overcharging and undercharging, and enhance the overall efficiency and longevity of the battery. These are some references which are used in my research paper. Thank you.
Okay. I have one question. So you have done the simulation part. No?
Yes,
have you
sir.
tested it on some real cells also?
No, sir. It is totally based on simulation.
Simulation. So which software you used for the simulation?
MATLAB.
MATLAB. Okay.
Thank you, sir. Now I would like to invite paper ID 199 to present his work on the topic, a study of photovoltaic inverter systems with MPPT and battery discharge controller for standalone application. Over to you, sir.
Hello, am I audible?
Yes, you are audible.
Uh, Hello everyone, my name is Sarthak Singh and I have pursued my BTech in Electrical and Electronics Engineering from Galgotias University, and today I am here to present my work on photovoltaic inverter system with MPPT and battery charging enabled charge and discharge controller for standalone application. So,
Just wait, Sarthak,
Just wait.
your PPT.
Not visible.
okay, yes, sorry.
It is not visible.
So these are the table of content of my work. So as we know that the
Yet shares.
Yeah.
what?
The PPT is not yet updated.
Yeah,
The
yeah.
previous one is still showing.
Wait.
Now it comes. Okay.
A second. Is it visible now?
Yes. It is visible.
It is moving.
Yes, it is moving. You can start.
Okay. So these are the table of content of my work. Now moving on further. So as we know that the sun is a source of solar energy and it is a clean and natural renewable energy source and with a very high long lifespan. And as a matter of fact, it is known that the total amount of energy that falls on Earth in a single day is sufficient enough to meet the entire requirements of human energy need in a single year. So we can say that the solar energy is very important for us, but the major problem is that the energy conversion efficiency of a solar PV system is quite low, as the PV cell shows a non-linear power versus voltage characteristics, and these characteristics are a function of of several uh, natural climatic conditions such as solar irradiance and temperature. And another issue that is related with the solar energy is that the energy that we have absorbed need to be stored, and for that we need energy storage. And uh, so for that, in this work, we have made an attempt to improve the energy conversion efficiency and also made an arrangement to store the energy that we have absorbed from the solar. For that, we have opted for the standalone PV system. And the standalone PV system, why we have opted for that is the reason is that it is quite easy to set up, and also because it makes the consumer independent from the energy because it is free from the grid, so it provides a energy independent status to the consumer. Also, the standalone PV system is a reliable source of producing renewable energy, but we can improve it by making a few changes, like changing the circuit or applying algorithms to get better efficiency. As you can see in the figure, the sun rays are falling on the solar PV system, and from that it is going to the charge controller, and the charge controller act as a medium to control the flow of energy, and the energy can go to the battery storage, or it can go to the directly to the appliance. But during the night time, when the sun is not there, the battery that is stored in the battery storage system, that will flow into the appliance through the inverter, which will convert the DC into AC. So as we know, there are many techniques, but one of the technique is the to improve the energy conversion efficiency is the MPPT technique, which is capable of extracting maximum power from the solar PV modules in real time. And maximum power point can be understood as a point at which the maximum power is delivered to the load, and at a specific ideal voltage. As you can see in the curve, there are various voltage values of voltage and current at which the solar panel can be operated, but there is a specific voltage and a specific current, as it is indicated by the arrow in the figure, at which we are getting the maximum power. This is the point of the maximum power point, and this maximum power point changes with the climatic conditions such as temperature and solar irradiance. As you can see on the figure on the left side, there are two curves. One is red curve and one is blue curve. So the red curve is for the 25 degrees Celsius and the blue curve is for the 40 degrees Celsius. And the circle on the red curve shows the maximum power point for the 25 degrees Celsius, and the circle on the blue curve shows the maximum power point for the 40 degrees Celsius. Now, yes. So, since the maximum power point keeps on changing, we have to track it, and we can use it track it using one of the algorithms. One such algorithm is the P&O algorithm, and P&O algorithm starts for the perturb and observe algorithm. So perturb stands for slightly changing. So we slightly change the value of voltage and current. Then we calculate the power, which is P is equal to V into I at each step, and this step is continued till till the power of the uh, of the system is increasing, and it has reached the maximum power point. As you can see in the left figure, the V and VPV and IPV from the solar panel are being sent to the MPPT, and the MPPT after calculating the power uh, uh, relates it with the previously attained power with the help of the relational operator, and then sends it to the MOSFET, which is acting as a charge controller. So this charge controller will then regulate the value of the voltage in the circuit, and then send it to the rest of the circuit as an increased power. And on the right side, we can see the this is the algorithm on which this MPPT is working, and the working is similar to the process I have explained here. The current power is then compared with the previous power with the help of the relational operator, and then with the help of many if and else condition, we reach the MPPT situation, and from there we can send the final increased power to the circuit. So this is the block diagram here. So from the PV system, the values of voltage and current are sent to the MPPT algorithm, and this MPPT algorithm, after tracking the maximum power, sends it to a charge controller. Now the charge controller, with the help of the DC-DC converter, regulates the value of voltage and current, and then sends it to the rest of the circuit, that is the battery and the rest the load. So after this, this is the Simulink model which we have constructed using the previous block diagram. So as you can see, the solar irradiance and temperature are being given as input to the PV array. Now from this PV array, the parameters voltage and current are being sent to the MPPT circuit above, and this MPPT circuit constantly monitors the value of voltage and current and sends it to the relational operator. This relational operator constantly measures the compare the power, that is the current power and the previously saved power, and then it is connected to the gate terminal of the MOSFET, which is also a part of the DC-DC buck converter, which is acting as a controller to regulate the voltage in the circuit, and then send it to the further circuit. Here we have connected a battery in which the charge will be stored, and after that there is a load, and before that we have connected a single phase full bridge inverter for converting the DC into AC, because as we know, most of our appliances work on AC. So these points I have already explained in the previous the simulation circuit. They are just the working of the that I have explained previously. So now coming to the result analysis. So as we can see, when I have disconnected the MPPT from the circuit, so before using the MPPT, the value of the power that we were getting, it was ranging from plus 8,000 watt to minus 8,000 watt, and it was randomly taking any value from plus 8,000 to minus 8,000. And the reason for that was because although our voltage was a bit constant, but our current was also deviating from plus 35 to minus 35, and the positive power indicated that the power was supplied into the circuit, and negative power indicated that the power was being absorbed from the circuit, because we have connected already charged battery which was about 45% charge, so it was taking power from it. That's why it was getting discharged during the time when the power was negative, and it was getting charged during the time when the power was positive. And since the voltage is not much deviating from it, it is also the reason why we have chosen voltage as the parameter, as a prime parameter for our perturb and observe algorithm. So as you can clearly see, after using MPPT, the power that we are getting is a constant power. Now this power is about 8050 watt, and at conditions like 25 degrees Celsius and 1000 watt per meter square solar irradiance, and the the rated power that of the solar panel that we have taken was about 8076 watt, and the power that we are getting after using MPPT is about 8050 watt. That means our simulation is working at an efficiency of about 99.66 percent. Also, as you can see, there are small variation in the voltage, and that is because it is being regulated by the voltage charge controller. And now even the current is not much deviating, and as a result of which the power is also not much deviating. In this simulation is similar to the previous simulation. The difference is only that it is working at solar irradiance of 500. Previously, we have taken the solar irradiance to be 1000, and that's why we are getting the maximum power of about 4025 watt, which is exactly the half of what we were getting previously. So this is the most important diagram, because as you can see here, at the time when we have switched on the circuit, at that time we were getting a power of about 80 watt. But with the help of MPPT, our power kept on increasing constantly, and it reached to the about 165 watt. And this power time curve is for just for a small single module. The previous simulations were for a array that consisted of 7 into 7 array, that consisted of about 49 PV modules. But this is for a single PV module, and that's why we are getting about 165 watt in just a small amount of about 0.5 seconds. And the rated value for the PV module that we have taken was about 165.8 watt. That means that
Sarthak, due to the time constraint, please wrap it fast now, because
okay,
other
okay, sir.
groups are also there. Still
Okay,
six
okay,
more
sir.
groups you have
Yes,
to
yes,
finish,
yes, sir,
right?
yes, sir. And as you can see, the battery current here is negative, which shows that that our battery is getting charged during this time. And also, our battery got charged from 45% to 45.0%, 0.01% in just about 0.41 seconds, which is also a very good time. And our battery voltage was also constant about this time. And finally, we have given the AC load voltage as a sinusoidal voltage, because our appliances work on AC, and we can also set the frequency according to our need. Here we have set it to be 50 hertz. So these are the conclusion. So we were successful to charge our battery of about 50 ampere hertz capacity from 45% to 45.01% in 0.41 seconds. Also, we have been successful in increasing the power efficiency of the current and voltage values to get the maximum power output by using P&O algorithm. And the MPPT provides an efficiency of 99.66%, which is very good and can match high-end commercial products. And this model has a very high potential to meet the expectation of real-life applications. And these are the references for my name. Thank you.
Okay, Sarthak, you please tell me that. Yeah, means you used only P&O algorithm, right?
Yes, sir. P&O algorithm only.
But you know that there are other algorithms also which can be used.
Yes, sir.
So have you tried those algorithms, or?
No, sir. Actually, P&O algorithm is based on the hit and trial method, and so it compares all the values that have been already like it compares one value with another value. So it is quite flexible with the other value, with the changes in the climatic conditions like the solar irradiance and temperature. So keeping in mind the simplicity of this algorithm and the flexibility it provided, so we have used the P&O algorithm in this one.
Okay.
Thank you, sir.
Thank you, sir. Next, I would request paper ID 277 to present their presentation on the topic, a comparative analysis of short-term load forecasting technique, conventional deep learning model versus proposed LSTM with attention layers. Over to you.
all the remaining participants try to finish within 6 to 7 minutes. Yes, 277.
Yeah.
ID can start.
Good morning, everyone. First and foremost,
First, share your PPT. Your PPT is not still shared.
yes, I think I've shared my PPT.
Still not visible for.
Yeah, is it visible now?
No, not yet.
Okay, 1 second. Is the PPT visible now?
Arrow is only coming, but still the screen is blank.
Okay, I'll just reshare it once.
The cursor was coming, but screen is still blank.
Okay.
Anybody can see? Anybody else can see the screen?
I think the previous
No, sir.
Sharing screen, that's right. Yeah, thank you. Yeah, is my screen visible now?
Now it is visible.
So, good morning, everyone. First and foremost, I'd like to express my gratitude to the organizers for this opportunity to present our research. I am Pragya, a student of MAIT, and our research paper is titled Comparative Analysis on Short-Term Load Forecasting Techniques, Conventional Deep Learning Models versus Proposed LSTM with Attention Layers. I'd also like to acknowledge my co-authors, Ravi Shankar Tiwari, Lakshmi D. Shuk Sharma, Neeru Nagpal, and Peruluge Sainu. Our research paper mainly focuses on
Please turn on your camera.
Yeah, sure.
Thank you.
No, I think okay.
So this is the content, the table of the content that I will move on to present. This is the abstract of my paper. So our research mainly focuses on a comparative analysis on short-term load forecasting techniques, including conventional deep learning models that I will continue to go on in detail. And it also with main focus on the proposed model, that is long short-term memory model with attention layers. It evaluates the accuracy and efficiency of both models using real-world data from past system in Delhi. The result shows the proposed LSTM models with attention layer outperforms the conventional deep learning models in terms of forecasting accuracy with a low mean absolute error of 1.9 compared to 2.35 for the best performing conventional models. So now moving on to the introduction. First, let's clarify what STLF stands for. STLF is short-term load forecast. It is a crucial component for power system management and energy supply planning. It involves predicting electricity demand over a relatively short period of time. Typically, it spans from around an hour to a few days. This prediction plays a vital role in ensuring grid reliability, enhancing energy efficiency, and it facilitates the integration of renewable energy resources as well. Throughout this presentation, we'll delve into various STLF forecasting techniques. It's also worth noting that the data sources include real-time data from a densely populated metro city, Delhi, as well as the weather data, including temperature and humidity levels. So let's transition into the proposed model that we'll follow. So first of all, we have taken the data sets on the hourly load basis with the weather data. After that, we have performed data pre-processing with a data set stacking and min-max scaling. We will go on to further detail after a while when I'll broaden into these topics. After that, we have taken 4 deep learning models for the comparison on the basis of the parameters that I have mentioned there, which are mean square error, the optimizer will be Adam, and the batch size is 32, and the epochs that we are taking is 100. So, moving on to the data pre-processing, as can see that we have utilized the RE data as I mentioned earlier. Subsequently, we concluded that the data preprocessing through data stacking with a lag of 48 and min-max scaling of our choice with the model that we have used works really fine, because the data that we have used is time series based. So that's why we have taken these data pre-processing models and went ahead with it. In dataset stacking with lag 48, the lag there refers to the input that it will take for predicting the next time slot. So basically what it means is that our selected models will use the current input will use the current input as well as the previous outputs from the earlier outputs to predict the forthcoming output, ensuring heightened predicting accuracy as we are taking up the previous question. Yes, sorry. Am I not audible?
Yes.
Okay.
Now you're not.
I can't hear you. I'm so sorry. I think there's some network issue on my end, maybe.
Now the voice is clear, but sometimes it is lagging.
Okay. So apart from dataset stacking, we have also went with min-max scaling, which typically is a scaling technique which ranges from 0 to 1. And in that, we select the different ranges and subtract the minimum and the maximum outputs. And that's how we move ahead with that. So so now I'll move on to my methodologies. As for the methodology, I'm so sorry, your voice is not clear.
Okay, you show your conclusions. Hello, Pragya, you show your conclusions.
Okay. So my contribution basically includes like the manuscript and the editing part of it mainly. But apart from that, would be
Off your video and just show your conclusions. Maybe that will help.
All right. So here we have compared all the 4 different models that we have been with.
Off your video. Maybe that will help the internet. And now start. Voice not coming. Pragya voice is not coming.
Yeah, is it audible now?
Now it is audible.
All right. So we have went ahead with 4 models. The RNN model, that is the recurrent neural network models, which results in a convergence of 0.05 by the 75th epoch. And it shows a residual plot with no sequence dependency, but reveals significant error linked to seasonality. GRU model, that is the gated recurrent unit model, also converged to a loss of 0.0 to a 0.05 by the 75th epoch, with no sequence dependency, just like the RNN model, and it again shows seasonality related errors in residual plots. The LSTM model exhibited near zero coverage by the 65th epoch, and the residual plots indicated no sequence dependency with notable error to seasonality. Now coming on to our model, LSTM model with attention. It combined the attention, because we combined the attention mechanism, it covered to a loss of 0.05 by the 75th epoch, but the residual plot demonstrated the absence of sequence dependencies, largely thanks to the attention mechanism. As you can see that the two major pre-processing techniques that we have used have the time series data in nature, as we referred to them in the data set. The outputs that you can see is largely like it is much better in the LSTM with attention loss, as also we have compared the metric aids in model evaluation. All the features of the six output nodes have input features from load and weather data, which affects the loss metrics. While a lower loss does not guarantee superior load forecasting, examining the residual value shows that the LSTM with attention exhibit less deviation compared to the model, making it a better choice. Now, to conclude our presentation, the accuracy and efficiency model using the real world data from a power system to conclude, the accuracy and efficiency of the proposed model using real-world data from the power system in Delhi, the study has provided valuable insights. The results clearly demonstrate that the proposed LSTM model with attention layers surpasses the performance of the conventional DL models in terms of forecasting accuracy, with a load MAE of 1.9 compared to 2.35 for the best performing conventional model. That, in our case, was the RNN model. So, moreover, the proposed LSTM model with attention layer improved the interpretability as well. The attention mechanism incorporated within the model allowed identification of significant input features that contribute to forecasting performance. This enhanced the interpretability and a deeper understanding of the factors influencing load forecasting outcomes, aiding decision-making process and power system. Although the proposed LSTM model has slightly longer training time compared to the conventional model, it exhibits a potential promise for the real-time applications in LTLF. The combination of high accuracy, interpretability, and reasonable training time makes it viable and effective technique for forecasting future load and demand of power systems. Thank you.
నెట్ పోయిన ఎంతసేపు నెట్ పోయిండే అదే ఇంకా స్టార్ట్ కాదు లేదు ఇంకా నాది రావాలి.
Okay, Pragya.
Yeah. Any questions?
Have you done any kind of hardware testing also?
No, we have just coded these, and we have mainly used
What software you use for that too?
Yeah, we have used Python for the coding.
Python. Okay.
Yeah.
Okay, next.
Hi, can you please share your title slide once?
Yeah, sure.
Just a minute. Okay. Thank you. Thank you, ma'am. Next, I would like to invite paper ID 288 to present his work on the topic implementation of evolutionary algorithms on day-ahead demand side management with unit commitment. Over to you, sir.
Okay.
All participants are taking 15 minutes. Try to finish your PPT within 8 minutes. So 1 or 2 minutes for the question hours.
Okay, sir. Is my slide is visible, sir?
Yes. PPT is visible. So you can continue.
Yeah. So the title of my paper is Implementation of Evolutionary Algorithm on Day-Ahead Demand Side Management with Unit Commitment. And the overview is introduction, literature survey, documentation, proposed method, result analysis, conclusion, and finally references. So introduction. In a day-by-day, the enhancement of load consumption is increasing with different types of consumers. So in order to overcome the generating units, transmission lines, distribution lines has to be provided which is a highly economic one. So in order to compensate or to overcome this one, they introduced the concept of demand side management. So demand side management is most important in a smart grid, which provide opportunity to the consumer participate in the demand response program. And demand side management is becoming a crucial in the area of dispatching and minimization of loads that are available. So in my math script, I have implemented day ahead demand side management for the decrease of load demand as well as minimization of cost. So cost is related to the utility bills. And here I have applied an optimization algorithm, NTIC algorithm, in the areas of residential, commercial, as well as industrial consumption. And same demand side management, day ahead demand side management is implemented on IEEE 39 bus system for the reduction of load, the same optimization algorithm, that is NTIC algorithm. And it is followed by the application of multi-object unit commitment. So unit commitment is nothing predicting the on-off status of the thermal unit in order to reduce the thermal power generation fuel cost. So the commencement of or solving the optimization problem of unit commitment can be done by using classical methods, heuristic methods, and meta-heuristic methods. So in my manuscript, I have implemented a hybrid method. A hybrid method is a combination of two or more optimization techniques. The major importance of a hybrid method is it is going to improve the overall performance, robustness, as well as convergence rate also. So demand side management incorporated with multi-objective unit commitment that will leads to the demand response unit commitment optimization problem. And this is some of the literature survey related to the unit commitment, which can be solved by using the classical techniques as well as heuristic and meta-heuristic methods. And this is the literature survey concerned to the hybrid method, which is a combination of two or more optimization techniques. And concerned demand side management literature survey is presented here. Problem definition. So the problem definition is a demand side management where a load shifting is going to be taken place. The main objective is to minimize the load consumption curve with the objective curve, which is represented in the equation 1. And load consumption curve is dependent based on the forecasted load as well as disconnect of the controllable loads of three consumers, that is residential, commercial, and industrial consumers. And objective load is going to depend on the mean value, maximum value, and price values that are going to be provided by the utilities, which is represented in the equation 2. And this is the multi-object unit commitment model formulation, where here the objective is to minimize the cost and emission, both are contradictory in nature. And the equation 4 represents the minimization of a total cost, which is a combination of cost function as well as startup cost. So the cost function is represented in a quadratic form, and A and B, which is represented in the equation 5, and the coefficients A and B and Cn represents the cost coefficients. And startup cost, which is associated with hot startup cost as well as cold startup cost. And it is going to depend on the number of online hours that are going to be turned on by the generators. And emission, which is another objective which has to be minimized, which is represented in a quadratic form. And T suffix n, E suffix n, and Fn represents the emission cost coefficients. And demand response unit commitment optimization problem is subjected to 4 constraints, that is power balance constraints, spinning reserve, power limit constraints, minimum uptime, and downtime constraints. And the proposed method. To solve the demand response unit commitment, a hybrid method is going to be proposed, which is the combination of non-dominant sorting genetic algorithm and population variant differential evolutionary algorithm. Here, initially, the population size and decision variables, mutation crossover, all the initial parameter values are going to be assigned, and afterwards, we are going to generate a random population. This population we are going to consider as a parent population. Afterwards, we are going to predict the fitness values of cost and emission functions. Half of the population is going to be solved with the NSGA2, and half of the population is going to be solved with population variant differential evolutionary algorithm. In NSGA2, non-dominant sorting is applied to obtain the rank of the parent population, and the crowding distance is going to be applied. Whenever the parent population having the same rank, this can be solved by using crowding distance. Is my voice is audible? Hello? Hello?
It's audible. Continue.
Okay, sir. Thank you. Thank you, sir. So during PVDE, the initial half stage of the population is going to be refreshed with the concept of interquartile range. Interquartile range is the concept related to the statistics, and genetic operators is applied to produce the half child population. Half child population from NSGA2 and half child population from PVDE that will leads to the total N population of child population. The child population as well as parent population are going to be combined to produce twice the population. And finally, N populations, that is original size population, is selected based on the fitness value of the parent as well as child population. This is the flowchart that is implemented for the solvation of demand response unit commitment. So at the initial stage, the parameters which are going to be assigned, and we are going to predict the fitness values. And for NSGA2, non-dominant sorting is going to be provided. That is, the population is going to be classified with ranks, rank 1, rank 2, and so on. That will lead to the friends. Each friend contains a ranking. Next, the mutation, polynomial mutation as well as binary crossover is implemented to generate the offspring. Offspring is nothing but a child population. Half of the population is going to be produced from NSGA2, and other half population is going to be produced from PVDE. And total population is going to be combined to produce twice the original population, and where we are going to be selecting only N populations based on the Euclidean distance. Euclidean distance is nothing but a range of distance where the points is going to be selected. And the result analysis. In the first case, with the application of demand side management, I'm going to reduce the peak loads as well as total demand with the application of genetic algorithm. And here, if we observe the table, three consumers are considered: residential, commercial, as well as industrial consumers are considered. And the peak load, the majority of the peak load is going to be reduced for in residential customers, but the total load is going to get reduced in the industrial customers. From the results from the graph, say in residential customers, the objective curve as well as the payload, that is consumption curve, is very close to each other. Hence, there is a reduction in the much more reduction in the peak load. But in case of industrial load, there is a maximum variation, but the total load in the industrial customers is going to get reduced. In case 2, the same strategy, day-ahead demand-side management, is applied for residential, commercial, and industrial for IEEE 39 bus system. And the same strategy is implemented for the reduction of load demand. And from the results from the graph, in industrial customers, both the objective curve as well as consumption curve are coincide. Hence, in IEEE 39 bus system, the total original load is 27,100. But in case of here, the load is going to get reduced much more in case of industrial because of minimization of objective curve as well as consumption curve. So the reduction will be more in industrial, that is around 23%, much more reduction. And this reduced load, a multi-objective unit commitment is going to be applied to reduce or to minimize the total cost as well as emission. So this is solved by using the hybrid method, which is a combination of NSGA2 and as well as population variant differential evaluation algorithm. Here also from the results, simulation results, it is predicted that industrial consumers are going to produce less total cost as well as emission. And this demand response unit commitment optimization problem is compared with multi-objective economic load dispatch and multi-objective unit commitment. Among these all three optimization, demand response unit commitment is going to produce the less minimization of fuel cost as well as emission. And from the conclusion, from the simulation results, it is concluded that industrial customers are exhibiting the much less reduction in the load as well as cost. Even in demand response unit commitment also, the highest minimization of cost and emission is going to be associated with industrial customer because of high power rating and long power time of controlling devices. The controlling device implemented in industrial consumer is very, very high, and it is going to take much more time. So more reduction is going to be taken place. And this is the references of my paper. Thank you. So any queries?
Okay, very thank you. Just one question. That simulation, have you tested some hardware also?
No, sir. Actually done on MATLAB, sir.
Okay, all the thing. Are you willing to test some hardware in the future?
Yes, sir. It can be implemented on the industrial side. We can be implemented.
Then it would be better, na? Than whatever you are testing
Yes,
in that computer, whether it is practically implementing or not. Okay.
Yes, sir. There is a pause.
Okay. Thank you. Next
Sir,
group.
thank you, sir.
Very thank you.
Thank you, sir.
Thank you.
Now
Thank you
I
very much.
request paper ID 316 to present his work on the topic design of fuzzy logic control for performance enhancement of PEM fuel cell system. Over to you.
Remaining students, just introduction part and like what is your problem and what are the results. Only that slides you show. Because it is already very getting late. We have already crossed our time. Next group.
Paper ID 316, please present your slides.
Title of my paper is the Design of Fuzzy Logic Controller for Performance Enhancement of PM Fuel Cells.
The slides are not visible.
Okay.
It is still that previous slide is showing. Wait, it is the previous one. 316.
Is it visible?
Yes.
It is visible. Just now, that introduction part and the results.
Go to the title slide for a moment.
This is the title of my paper, Design of Fuzzy Logic Controller for Performance Enhancement of PM Fuel Cell System. These are the table of contents. These are the objectives. Mathematical modeling of PM fuel cell system in MATLAB and designing a fuzzy logic controller for performance enhancement of fuel cell systems and MATLAB simulation of fuzzy logic controller. The effect can be minimized using supplementary information about the process. So introduction of among the different green power technologies, that is wind power, photovoltaic, microturbines, and the fuel cells. The fuel cell distribution generation is considered one of the most promising technology due to the high operating efficiency, reliability, and high potential capability. Fuel cell provide clean and effective energy production for fixed and mobile applications. PMFC uses one of the simplest reactions of any fuel cells. Hydrogen and oxygen are supplied to each side of the cells. The cell consists of PM with a catalyst layer on each side. The approximate linear or non-linear systems descriptions are applicable in a it is preferable to use adaptive controller in the circumstances to achieve the control objectives. These controllers are better suited to achieve the desired control objective in the presence of floating disturbances. Fuel cell performance depend on a careful balance of the right temperature, humidity, reactant pressures, purity, and flow rates. As a result, efficiency of a control employed has a direct impact on how a fuel cell is performed. The parameter of fuzzy logic controller is often tuned using a hit and trial methods. The main requirement of creating a PMFC system based on this is the choice of scaling factor, proper membership functions, variables, and the related rule tables. Literature reviews the mathematical modeling of the PM fuel cell systems need to be developed in order to analyze the dynamic behavior of nonlinear PMFSC systems. A control method using a fuzzy logic controller to regulate the fuzzy voltage at the output of the DC-DC converter is presented in. A fuzzy logic based controller is created because it has a high performance of cost ratios and relatively minimal design and implementation cost. The fuzzy logic controller is employed to get over some PMFP systems inherent drawback like uncontrolled high overshoot and current ripple. Additionally, nonlinear adaptive fuzzy controller provides a better performance when dealing with changing parameter and disturbances.
Methodologies are the modeling of fuel cell system with controllers, designing of the fuzzy logic controller for performance enhancement of fuel cell, and MATLAB simulations. These are results. This is the mathematical Simulink model of fuel cell system with fuzzy logic controller, and this is the result of the Simulink model without any controller, where the uh, and this is the output current, voltage, and power of the system with fuzzy logic controllers. And the conclusion is the proposed controller is able to handle the nonlinearity of PM fuel cells, and it is anticipated to be successfully answer to the challenge of management of PMFC's output voltage. The nonlinearity shows dynamic and small limitations make it difficult to regain voltage of PMFSCs, which further complicates their uses. The simulation illustrates the fuzzy logic controller has the advantage of no overshoot, no oscillations, and less saturation times. The suggested controller performs better under control and is a more efficient control property for the modification of the real voltage and current distribution than the system without a controller. Thank you.
Any questions, sir?
Which software you used to make that?
What, sir?
Which software is used?
MATLAB.
And have you done any kind of hardware testing?
No, sir. It's a MATLAB solution. Thank you.
MATLAB. Okay. Next.
Thank you. Next, I would like to invite paper ID 368 to present their topic, which is effective load frequency control of electric network system with PID controller based on Prairie Dog optimizer. Over to you.
Hi, sir. Is my voice audible?
Yes, you are audible.
Okay. My name is Yazid Kharsan from Lovely Professional University, Punjab. My paper title is Effective Load Frequency Control of Electric Network System Controller based on Prairie Dog optimizer. We know that power system is a very complex system. So in load frequency control, we need to balance the load and the generators. We know loads consumers, they need to rise and fall the loads. So we need to maintain the frequency between the generators and load. And frequency is a key stability of the power systems. This is my proposed model. I use MATLAB to create this model. We have two areas to control the load frequency for these two areas. Each area consists of two different sources. One is a thermal power plant and second one is gas turbine power plant for both area. And between that there is interconnected interline. We need to maintain the frequency for frequency 1 and frequency 2 and frequency tie line. The objectives of this research paper is to regulate the power output of the electric generator within the area in response to change the system frequency and tie line loading. We use a PID controller based on optimization technique that called Prairie Dog optimization, and I compared between another optimization technique that already used HHO controller based on PID controller also, HHO optimizer, sorry, based on PID controller. And these two algorithms, I evaluate the performance for those two methods in order to find the settling time and peak overshoot and undershoot. As you can see here in this table, this is our results for the two different methods, transaction method. One is called unilateral transaction method, or we can say Polko company transaction method. The second one is bilateral transaction method. I compared two algorithms, my novel proposed algorithm PTO, prior optimization, and HHO optimizer for finding the value of proportional and integral and derivative values for the PID controller. The second table here is showing for frequency for area 1 and area 2 frequency and tie line frequency. to find the overshoot and undershoot and settling time for both BDO and HO optimization techniques. These figures show the graph for the frequency in the based on the time. So as you can see here, there is two different objective function we use, one called ITAE and second one ITSE. ITAE integral time absolute error and ITSE is integral time square error. And we found that BDO based on BID controller with ITAE is more, it has more performance than another optimization technique, which indicated by green line. And this is the frequency for area 2 for same methods, and this is for tie line. In conclusion, we can say in this paper, I use multi-area, multi-source power system to create for gas and thermal non-reheat turbine. And I use two different transaction methods. One is bilateral, and the second one is pole co-transaction or unilateral transaction method. As I told you earlier, I have used two different. One is my proposed technique is called BDO, and second one it's HHO, Harry Hawks optimizer. I compare these two with different objective functions. One it's ITAE and one it is ITSE, and I found that BDO based on BDO BID controller is more. It has more performance than HHO BID controller in terms of having less time, settling time, and less overshoot and less undershoot. Thank you, sir. And this is my references.
Okay, Yazid.
So, any questions?
Any questions, sir?
Hello, can you hear me?
Any question? Yes, sir.
Can you hear me?
Yes, I can hear.
Okay. My question is that, what is the practical application of your research? Or in which field it can be implemented?
I have not done any practical research. It is only based on simulation. I use MATLAB software in this area.
But the application should be somewhere, no? Like.
Yes, we use this in substations or in electric stations like
power generation.
Power generations, yes. In thermal and gas power plants. Yes.
Okay.
Thank you.
Thank you. Next, I would like to invite paper ID 431 to present their topic, which is robust sliding mode controller for flyback converter in continuous conduction mode. Over to you.
Audible?
Please share your screen.
Yeah, sure. Okay. Hi, good afternoon to all the members. So I'm Mukund Kumar Chaudhary and I'm from NIT Kurukshetra. My paper title is Robust Sliding Mode Controller for Flyback Converter in Continuous Conduction Mode. The outline of paper is...
Please enable slideshow.
Yeah, sure.
Thank you.
Okay. The table of content of the content of the presentation includes introduction, the related work, the proposed model, the analysis, conclusion, and the references which I have attached to the PPT. And now, first of all, like what is a flyback converter? So it's a basic common topology which is used in voltage conversion application. How it works? It works on the storage and transfer of energy is the basic principle for the flyback converter. So it makes use of transformer to store the energy in the primary winding when the MOSFET switch is turned on, and it releases to the load when it's off state. Flyback action in which the transformer stores energy in the magnetic field during the on state and releases it a voltage secondary during when it is off for the energy transfer. Okay. Now, so this is about the flyback converter. The main focus is on sliding mode control technique. So the thing is, what is sliding mode control? So sliding mode control is a non-linear control method that employs a switching action to force the system state to slide along the prescribed surface termed as the sliding surface. So what happens in sliding mode control that we have whenever we model some converter or some system, we have the state variables for the system. In sliding mode control, our approach is that whatever the state variables we have, we try to put those state variable on a sliding surface, or we can say our desired output, and we want all those state variable to be slide on that desired surface. The main characteristics of the sliding mode control is robustness towards the variation in the characteristics and the uncertainties to the parameter. Uh, how the uncertainties to the parameter? We can take an example like when let's suppose we have a submarine underwater submarine and it's flowing in the water. So some of the uncertainties which are known to us like low tide and high tide. So from underwater vehicle we can say okay the low tide and high tide we can conclude, but the for the tsunami it will not work. So the whatever the uncertainties which are known to us, this control strategy is applicable to only that system. Okay. The general idea of sliding mode control is to design a dedicated trajectory path in the control law that will direct the control trajectory of the state variable towards a desired origin. The entire sliding mode control process is divided in two phases. One is the reaching phase. What we done in the reaching phase that the controller will drive the trajectory regardless to the converge of the sliding surface, and upon completion of the reaching phase when the trajectory arrives within a small vicinity of the sliding surface. Okay, now second phase is sliding phase. The controller will give series of switching actions such that the trajectory is maintained within a small vicinity of the sliding surface and is concurrently directed towards the desired reference at origin O to achieve steady state operation. I will explain both these phases in the next diagram. Okay, so as I mentioned, one is the reaching phase and one is the sliding phase. So this is our reaching phase. What we are doing that whatever the state variables we have for the flyback converter, let's suppose this is the output voltage you want to track for instance. So the whatever the state variables we have, we will try to put all those state variable on this sliding surface, and so this is the reaching phase. Once all those state variables reach to this sliding surface, we want that all those state variables should follow this path. Okay, so this is called the reaching phase, and this is called the sliding phase. Okay. Now next, what the related work have been done to this? That this is our basic flyback converter model. First, I will explain how it works. That in sliding mode control, what happens that when we turn at what is happening on and off state. In the on state, our switch MOSFET is turned on, or this diode is turned off. So in this way, this primary of the transformer will store the energy, and in the secondary, this MOSFET switch will go turned off. This diode will get turned on, and whatever the energy stored in the primary, it will deliver to the secondary. So in this way, our flyback converter works, which I have mentioned in the first slide, that it stores the energy and release the energy. So this is the basic functioning. So what we have done that first we select the state variable x1 and x2, where x1 represent the current in magnetizing inductor and x2 refers to the output of the capacitor voltage. Now what happens when the converter is in on state? On state means our switch MOSFET switch is on and our diode is disconnected. So during on state of the converter, we can represent the state space equation in x dot equal to a on plus x, a on into x plus b on for 0 to t on. The t on is the time period for which our MOSFET is turned on, and where a on is is the on state matrix which is represented in this way, and b on in this fashion. Now when our MOSFET is during off state, how this converter will work. Okay, in off state, in off state, what will happen that this slide has some wrong. Okay, this MOSFET should be turned off, and this should be connected. Okay, and in that case, we got our matrix in this manner, in this fashion. Now, after having the state space equations for the converter, we will go for the selecting the sliding surface. So for flyback converter, what parameters I have mentioned, that is, one is my inductor current, magnetizing inductor current, one is my output capacitor voltage. So these two things are my parameters. Now I have chosen a third variable also, P3. Why we have chosen P3? Because in a fixed frequency control, to reduce the steady state error, an extra control variable P3 is introduced for that surface, for that purpose. The sliding surface, which is designed, is a linear combination of state variable, and it can be represented as gamma 1 into P1 plus gamma 2 P2 plus gamma 3 P3, where gamma 1, gamma 2, and gamma 3 are the gains for the system. So this is a proposed MATLAB simulating model. In this, what we have done, that this is this is the main layout or fundamental layout of our of flyback converter. I have put a DC voltage source amplitude to put the variation in the input side of the voltage. This whole part is the sliding mode controller for the flyback converter. Okay, this 20 is our reference gain. This is the current. This is the limiter or hysteresis limiter is used, and I have the PWM signal. This model works on the inner current control, outer voltage loop method. Means I have taken two feedback. One is from the output of the voltage, and one is from the input of the magnetizing current for this same purpose. The parameters which I utilize for designing this converter, that the input voltage is taken 10 volt, the output voltage is taken 20 volt, sorry, load resistance is taken 100 ohm, the output filter capacitance has value of 470 microfarad, primary windage leakage reactance is 100 microhenry, the switching frequency is 30 kilohertz, and transformer ratio is used is 0.5. Okay, now what happens, like, first of all, what we have done, that when we try to vary our reference voltage is our desired voltage we want to achieve. Let's in this case, 20 volt is the voltage we want to achieve. So okay. So in this, what we have we tried to change the reference voltage. When the reference voltage shifted, what we observed, that our converter our converter is still like in the process, is able to track the voltage measurement and the load resistance path. When we try to change the input voltage variation, that is from the input I mentioned, that is 10 volt. From 10 volt to 12 volt, I try to reach, like this is 10 volt to 12 volt. In this case, what happened, that still our converter is somehow tracking this 20 volt output voltage, and our output resistance, like still it has no disturbance when you're trying to change the input voltage. In the previous case, we've seen for the reference voltage. Now, what will happen when we try to put the disturbance in the load resistance? Like we are using 10 ohm at the load resistance, but we try to go for the 20 ohm. So when we go from 10 to 20 ohm, still in this condition, when we run on the MATLAB Simulink, we found that our controller, which is designed, it is perfectly able to track the output voltage or the desired output voltage which we want. Okay. So what is the conclusion from this thing is the design of sliding mode control, we can conclude that it is a non-linear control method technique, and that aims to drive the state variable onto a specific sliding manifold and maintain it on the surface regardless of uncertainties and the disturbances. To verify this thing, what we have done, like we have put disturbances by varying input voltage, output load resistance, and the reference voltage. And we found that still our controller, which is designed, is managed to track the desired output voltage and inductor current. Its robustness to the uncertainty, insensitivity to parameter variation, and ability to handle nonlinear dynamics make it particular system suitable for the system with complex and uncertain dynamics. The dynamics which I have mentioned, one for the underwater system, This SMC can be successfully applied in various control applications like power electronics. From power electronics, you can say like one application I mentioned for the flybit converter. It can use in the EV, like we have onboard charger. It can use in robotics, aerospace system, and automotive systems. Okay, so these are the references which I have taken for this paper. Yeah, it's all about the paper. Thank you.
Any questions, sir?
Very thank you. No questions.
Okay, thank you. Thank you.
Okay, Mukund.
Thank you. Next, I would like to request paper ID 495 to present their work on the topic design of type compensator using K-factor method. Over to you.
Am I audible, sir?
Yes, you are audible.
Thank you, sir. So thank you for giving me this opportunity to present my paper and this conference. So I'm Adnan Mukhtar. I'm currently pursuing PhD in the Department of Electrical and Electronics Engineering at SRM University in the Power Electronics and Control Group. So the title of my presentation is Design of Type Compensators using K-factor method. So this is the outline of my paper. So let me start with the introductory part of this paper. So first, the motivation of the type compensators. Since I have done a lot of literature survey on design of type compensators using K-factor method, but I have not found a single paper where there's a proper procedure of designing type compensators using K-factor method. So this why I use this K-factor method for designing type compensators because it acts as a base paper. If we take suppose particle swarm optimization algorithm, genetic algorithm, honey badger algorithm, or different so many optimization techniques. So this technique acts as the base for these optimization techniques, because in those techniques we have to set lower bounds and upper bounds. So we can calculate those bounds from this algorithm. Now, if we talk about some control systems, usually power electronic converters, DC-DC converters like boost converter, they are non-minimum phase in nature. So due to this non-minimum phase behavior, the output response of such converters have initial undershoot, which is basically due to less phase margin, or I must say low phase boost. So in order to avoid this undershoot so that the performance should be good, we are switching to these type compensators. Now, compensator design. As we know, compensator design is a crucial aspect of the control systems because it ensures us in designing the favorable dynamic performance and stable regulation that we want to achieve. Moreover, we can achieve the performance of our system in terms of transient response, steady state response, or we can say in time domain form as well as frequency domain form in the form of phase margin and gain margin and crossover frequency. Now, if I will talk about the type 2 compensator and its comparison with the already conventional compensators that is available in the literature, like I have lead compensator, but the problem with the lead compensator is that it only provides a phase boost up to 45 degrees, and most of these this boost converter, they have a phase margin phase boost below 45 degrees. So in order to provide an additional boost of 45 degrees, which is in general 90 degrees, we are switching to type compensators, actually type 2 compensator. So this type compensator actually belongs to the category of lead compensators with integrator, which is basically a pole at origin. So the main reason why we are using this type compensator, because it is providing a phase boost of 90 degrees. But in order to design whether type 2 compensator or type 3 compensator, some information about the system that we are considering is necessary. So basically there are two parameters that we need to consider. Like we should know, it should be known to us phase margin and phase crossover frequency. So this phase or crossover frequency is basically the geometric mean of the pole frequency and the zero frequency. So this is the mathematical procedure. So actually what I have done in this paper is basically I am designing a proper step-by-step mathematical procedure for designing these type compensators using K-factor method. So this is the transfer function representation of type 2 compensator. So the main aim is to derive this DC gain K2C, the zero frequency and the pole frequency of this compensator. So we can take this from basically there is a mathematical equation by which we can calculate these parameters. So first, suppose we are considering a non-minimum phase boost converter, which we are representing by some transfer function, strictly proper transfer function, which can be derived by small signal methods, or we can use some state space equations can be also considered. So we will take we will draw the Bode diagram of that transfer function, and two parameters that we actually need will be achieved from those, that is phase margin and gain margin. Phase crossover frequency. So in order to calculate the phase boost, which is basically for type 2 compensator 90 degrees minus phase margin. So this crossover frequency that we have achieved from this Bode diagram of the system considered, it is actually W omega 2C, which is basically the geometric mean of pole frequency and the zero frequency. Now, if we talk about the type 3 compensator, it also belongs to the category of lead compensators, but lead compensator with one additional pole at origin. It is basically, there are two poles, two zeros, and one pole at origin. Two zeros are basically in dominant, I must say, dominant zeros, which are close to origin or imaginary axis, and two zeros which are far away, which are basically insignificant or ordinary. So the another advantage of this type compensator is that it provides further phase boost of 90 degrees. In total, it is 180 degrees. So this is the mathematical representation of this type 3 compensator that I have derived. So now K-factor method. Now, if we talk about this K-factor method, the K term, it is basically the measurement of spacing between the insignificant pole and significant zero. So that's why it is known as separation factor. Now, if we talk about type 2 compensator, so this K parameter is basically the square root of ratio of pole frequency to the zero frequency, while in case of type 3 compensator is the ratio of double pole frequency to the double zero frequency. So in order to design a compensator for a control system, some of the information should be known to us. First is system model. So a mathematical simulation of the system or plant we want to manage. The model should provide proper detail of the transfer function, whether state space representation or any appropriate method, and it represents the dynamic response of the system. Now, control objectives. So control goals that should be clear and well defined, such as desirable closed loop performance, stability margins are there, disturbance rejection is there, noise attenuation, or any other requirements that compensator must achieve. Now, if we talk about compensator structure, like we have PID controllers, there type 2, type 3, lead, lag, type 2 compensators, and type 3 components frequently employ this K-factor approach because they have two additional parameters, this DC gain and one pole at origin. Now, if we talk about frequency response analysis, which is the main component for designing type compensator, because phase margin and gain, this crossover frequency comes into this component. So for K-factor tuning methods, that is the main method we are doing. So for type 2 compensator that I have already told you, it is the ratio of square root of pole frequency to the zero frequency. And for type, so in order to calculate three parameters, first parameter is pole frequency, which you can see here is the product of this K-factor term and this crossover frequency, which can be obtained from the Bode diagram of the transfer function considered. So similarly, for obtaining the frequency of the zero, it is the ratio of the crossover frequency to the K term. Now, so at last, the K term can be achieved by taking the tan of this 5B2, which is basically the maximum phase boost for this type 2 compensator. Now for type 3 compensator, I told you it is the ratio of double pole frequency. It's actually omega 3p is the double pole frequency. So, omega 3p, which is basically the double pole frequency of pole, is basically the square root of this k term multiplied by this omega 3c, which is the crossover frequency. Similarly, for 0, it is ratio of crossover frequency by under root of k. So, for this type 3 compensator, it is the under root of k tan of phi b3 divided by 4 plus 45 degree. This is the mathematical equation by which we can calculate the value of k. So if we talk about the advantages of this compensator, these type 2 and type 3 compensators, I must say there's a simplicity and ease of implementation, versatility is there, stability, robustness, and minimal computational complexity is there. So why they are simple? Because there are only few algebraic expressions that can be used, so it's not time consuming. So this is the main advantage. And it acts as a base method, already told you, for optimization techniques that already discussed. Now, if we talk about the versatility of this technique, now we have numerous control systems which can be benefited from the flexibility and applicability of the k-factor technique. Now, if we talk about stability and robustness, by methodologically adjusting the location of poles and zeros, we can use this k-factor technique, and engineers or the control system users can enhance the system's reaction to uncertainties and shocks, guaranteeing the steady and dependable performance by carefully choosing the K factor. So these are some of the advantages. Now, if we talk about the disadvantage of the system, so it requires deep system knowledge. As I already told you, the system should be known, and the parameters that we need to achieve are phase margin, crossover frequency. Then we can design this type compensator using K factor method. Now, lack of optimization. So optimal parameters can be achieved. I already told you that we need some optimal optimization techniques like these particle sum optimization, so as to achieve the optimum parameters. But no doubt it is a disadvantage, but it provides the base for these optimization techniques. Now, these are some of the applications where we can use these type compensators with K factor, like we have buck converters, single inductor, single input, dual output converters, coupled inductors, pseudo buck converters, as well as for the boost converters, which I am currently working on. So, talking about the conclusion, we can say it is the effective parameter or tool for designing control systems so that we can achieve better performance or regulated performance. And moreover, these type compensators help us to attain maximum phase margin up to 90 degrees, which is good for the stability of the system. These are some of the references. Thank you.
Any questions, sir?
Are you planning to test it on some hardware also?
Sir, yes, we are currently working on couplet inductor pseudo converter. So we have done the simulation part is done. Now in the coming days, we will do its hardware also. Thank you, sir.
Thank you. Now I would like to invite paper ID 445 to present their work.
One second, sir.
I request paper ID 445 to present your work.
Adnan, remove your PPT.
Sure, sir. Done, sir?
Is it visible?
Yes, it is visible.
On your camera also.
Hello.
You may start the presentation.
Okay, thank you for the opportunity. I'm Vishal Shah. We are going to present our research paper, which is based on modeling and performance analysis of model predictive and feedback linearization control UAV autonomous quadcopter drone in 3D analysis. Here's the outline of this paper. As an introduction, actually we are
autonomous drone is resolving the industrial safety and security modeling. In this paper, we just analyze the result of the safety security of the drone and uh, and the in this paper we are use the useful data to uh, demonstrate the drone mechanism and in the UV method I used to demonstrate the safety security operation and the additionally this is the utilized to provide the uh, meals, the pictures, film videos in additional uh, um, medical supplies for this drone technology. Then in methodology, this research is focused on develop and implementation of sophisticated control system that combines the model predictive control techniques and feedback mechanism to facilitate the autonomous flight in three-dimensional space. This attempts to provide the drone scalability, uh, manuality, and overall performance by utilizing the sophisticated mathematical model and real-time data processing. The flowcharts of models showing the methodology of the drone mechanism, and we use some gravitational or for drone there is some issues with gravitational drags and um, balance, so we used analysis those analysis those analysis this problem and use use those mathematical to solve the problems and as a result analysis uh, we demonstrate some models for uh, drag forces for uh, for for drag forces and for environment we analyzes the uh, uh, results and here we analyzes the performance concerning controls analysis and using using Python code we analyze the 3D models the drone controls and develop uh, those models and in conclusion part autonomous drone can be useful for multiple purpose. The authors design for proper drone using MPC control and feedback linearization control using these different uh, trajectory. The drone performance is analyzed. This kind of drone can be useful for uh, driving emergency supply or food supply like that, and the drone can be improved using un, like unsupervised machine learning based planning like that. And here is some references and here is some references we have used to develop the
models. Thank you.
Okay, Mr. Saha.
Yes.
Hello, can you hear me?
Hello. Yes.
Have you done some testing on the drones? Tested your algorithm on the drone?
Actually, sir, we are just develop models and analyze on software based, sir.
So how do you find that the 3D dynamics is improved?
Sir, actually,
just show your results.
Yes, sir. Using UAV motion drag force, we analyze the results.
So, which software it is?
Yes, sir. It's software based Python. Python code analysis. Basic.
So, how much you improve that dynamics is how much percentage improving here in your simulation?
Actually, sir, can you come again?
I'm asking now. You have compared. So, how much percentage it is improved in your method as compared to the previous method?
So actually, we analyze and like here is some result we analyze. Actually, my group member is doing that. Actually, I have less idea about the result.
So how would I know that yours is better than the previous method? Because drones are already stable, so they are already maybe using some 3D dynamics to make it stable. That's your work is, no?
Yeah, yes, sir, yes, sir.
So that is what I want to understand, that how your is better than the previous.
Sir, actually, in so many references we have used, like like for UAV we got the like we are expecting the result, we got that result like using those model like previously used model we have analyzed, and like this model we also analyzed and we got the result.
Okay. Okay, sir.
Okay.
Thank you.
Thank you. Can I stop sharing?
So now I request all the participants to turn on their camera.
Excuse me, ma'am.
All the participants to turn on their camera.
Excuse me, ma'am.
Yes.
Hello. Ma'am, we have received a request on WhatsApp that we have to share our screen. My paper ID is 199.
What is your paper ID?
199.
199. Okay, you can share once your title slide.
Okay, ma'am. Is it visible now?
Yes, it is visible.
Okay, I am turning my camera on also.
Okay. Please.
So let me just.
Yeah, you can unshare your slide.
Okay, so you have taken the screenshot, ma'am?
Yes.
Okay, okay.
Ma'am, what's about paper ID 6?
Okay, you can also share once.
Okay.
Now I request all the participants to please turn on your camera, and please paper ID 6 you can unshare your screen so that we can have a group photograph for all the presenters along with the session chair.
Three, four participants have left. That's just.
Okay, so
Just a minute.
so we can smile, everyone. So clap for everyone. So I thank all the participants for their participation and for presenting their paper and for presenting their ideas. Now, I request our session chairs to give the concluding remarks.
Very thank you, madam. It's my honor to do the session chair for this RDCPAE conference for the control is related topic, and the topics that I see shown by the different researchers are very good quality. Most of them are, I think all of them are simulation based, so it is good that in the future that you also do some kind of practical some field related trials also for that simulation, so it would be much good that what is the actual outcome, what is showing in the computer and what it is showing in the ground. All the research that have been shown are very good. They have done a lot of hard work for doing that work. With that, I would like to thank you to all the presentees also in the management of the MIT. Thank you, madam.
Now I request Dr. Pankaj sir to please share your views. Pankaj Mukhija. Is he there?
I don't think so.
Okay. Okay, then this is all. So thank you everyone once again for joining this technical session. So after lunch we are having our industry session. So I'll be sharing the link with all of you. So all of you are requested to join the industry session as well as the valedictory session. Thank you everyone.